Hello and welcome to our video on Newton's first law of motion. You can see the picture of Sir Isaac Newton on the page here. And Isaac Newton created three fundamental laws of motion that we still use today. And this video is going to focus on the first law of motion. But before we can even understand Newton's laws of motion, we first have to have an understanding of what forces are. And forces are any sort of push or pull on an object. So, you push a book across a desk, you pull open a door. Those are examples of forces. Forces always come in pairs. There's never just one force. There's always another force along with it, and we'll get more into that part later. But forces are also vectors. They're vectors because they have a magnitude and a direction. And remember, we represent vectors with arrows. So a force can be represented with an arrow. Also, forces affect the motion of objects. So if an object is already moving and some sort of force is applied to that object, then it will change the object's motion. And we represent forces with the unit of newtons. So just like whenever you buy something, you buy it with dollars, $5, the unit is dollars, or you're driving 50 miles an hour, your units are miles per hour. So with a force, the unit is newtons, and if you didn't catch on, it was named after the guy Isaac Newton. And a couple examples of forces are gravity and friction. So diving into Newton's first law, it is also a lot of times called the law of inertia. Now, what is inertia? Inertia is an object's ability to resist change in motion. So if an object is just sitting there, how difficult is it to get it moving? Or if an object is already moving, how difficult is it to change that object's movement? And also, the more mass an object has, the more difficult it is to change that object's motion or direction. So let's say, for instance, I have a rock sitting on a desk, and I also have a piece of paper sitting on a desk. It will be more difficult to move the rock because the rock has more mass than the piece of paper, and inertia is directly related to mass. So if I'm trying to move these two objects, the rock will be more difficult to move than the piece of paper because the rock has more inertia than the piece of paper. If you were to read Isaac Newton's law the way that he stated it, it would say something along the lines of an object at rest tends to stay at rest, and an object in motion tends to stay in motion with a constant speed and in a straight line unless acted upon by a net force. You could simply say an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted on by some sort of force. If you're confused by the term net force, a net force is any sort of unbalanced force. So we have multiple forces acting on an object. If those forces are unbalanced to a point to where there's more force in one direction, that will be the net force, the direction where there is more force. And a couple examples of Newton's first law of motion. One of them would be a pencil that is just sitting on a desk. That pencil is not going to move unless some sort of force is acted upon it. Say, for instance, your hand or something of that nature. Another type of force would be a tug-of-war battle between two equally matched teams. And if they are pulling in opposite directions with the same force, there's going to be no net force. So let's say, for instance, I have two teams of people in a tug-of-war battle. And here's the rope right here. And they're pulling, let's say this team over here is pulling with a force of 500 newtons. And this team is pulling on the other way with a force of 500 newtons as well. Then that will show that there's no net force. The forces are completely balanced. There's 500 newtons going to the left. There's 500 newtons going to the right. The forces are equal. Therefore, nobody's going to move. And this is sort of an example of Newton's laws. There's a net force being applied. There's no net force being applied. Therefore, the total force combined would be zero, and the object would just be at rest, which in this case is the rope. And another example of Newton's first law of motion would be a spaceship that is sent into space, and after it's in space, the engines are cut off. The spaceship will continue moving in a straight line with that same velocity until some sort of other forces act on it, such as gravity, or unless it collides with another object, or unless the engines turn off. So all those are examples of Newton's first law. The spaceship's going to keep moving unless it's acted on by some sort of outside force, such as gravity, or unless it collides with another object, or unless the engines decide to turn on and affect the object's motion. So Newton's first law, an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted on by some outside force.